yeah, yeah, I'm gonna record it. So if you need to meet Toronto Green standards, you have to build Energy Star. It's mandatory.
So why did
So,
you do passive, Jack?
sorry?
Why aren't you at passive as well if you've accomplished all of those
Yeah,
books?
I will explain. Passive house is very focused on just low energy consumption. They don't really think about affordability
Oh,
and flexibility. So, because when you talk about energy efficiency, there's something called diminishing return. So, when you put in, a decent amount of insulation in the walls, you get your optimum energy saving. And even if you spend like $30,000 more of installation to make that wall more energy efficient, the performance of that wall is probably only 5 to 10% more efficient. But the energy saving is not 5 to 10% more energy efficient. It could be only 1 or 2% increase. So the incremental cost versus energy saving is not very practical.
hmm.
That's something I don't believe in, because
Okay.
for me, affordability is the most important thing for most homeowners. So anyways, I mean, we can have that chat later. Let's talk about building code. Now, what I did is I sent you guys some attachments on the chat. You guys see it?
Yes.
You guys see that?
Yes, we do.
Okay, so this is an exercise I send with all but CBOs, because part of SB12 prescriptive path is to understand how to comply with the prescriptive table. So the first session, we're gonna have 2 sessions. The first session, I'm gonna walk you through all the prescriptive requirements of SB12. That's today.
Okay.
Next Tuesday, we're gonna focus on SB12 performance compliance.
Right. So is this what you sent us today? Is it a homework or something we have to open up and look at while you're giving us this session?
I'll let you decide what you want to do, but I'm gonna walk you through an example of how to calculate effective R values, and then it's
Mhm.
up to you guys to, if you want to do homework or not, just to like further development.
Okay.
I like to learn, so for me, there's that aspect of continuous learning and things like that. So if you guys are up for that as well, then it's really a good document to have. All right, I am sending you another document.
Oh, more?
Yes, because it has my notes in it. So you download the version from the government. There's no like cheat sheets. I have notes that I highlighted in my document, because I use the same process to train my staff. So I'm sharing that with you guys so that you guys can have these highlighted files, so that you can review it at a later date. It's easy for you to pick up what I'm telling you right now. So I'll reset everything later so that you guys can see it. But for now, let me start sharing my screen. And if it crashes, because my screen doesn't like me, but so let me show you guys this. Okay, so all of you should be able to see my screen. Is it hard to see, or you guys are okay with what you're seeing right now?
It's a bit small, yes. Let's see how we can make it bigger.
Okay, so you know what? Let me stop share. I'll just share just the I will share just the PDF, because I have a very large screen at home. So when I share the whole screen, it's harder for you guys to see. How about
This
now?
is much better, yes.
Okay,
Me,
awesome.
at least. Anybody else have any problems? Silence. Okay, good.
Silence is good. Okay. All right. Let me walk you through quickly about the SB12. So if you're building in Ontario, there's something called SB12, and that is the supplementary standard. So that's SB12. So supplementary standard SB12, and it's energy efficiency for housing. Right? There's the most recent version is July 2016. That's this version here. Now, I can tell you that there's 3 chapters. There's 3 chapters in this document. This document is only 67 pages long. The first chapter is about scope, application, terms, and abbreviations and reference document. This chapter is not very important. Chapter 2 is also not important because it's obsolete. Chapter 2 was enforced before January 1st, 2017. That is 6 years ago already. So we don't do any of this. So really chapter 3 is what you're going to study with me today. So chapter 3 is what we're going to focus mainly on. And page 26 is where we're going to start. All right, so let me talk to you about chapter 3. So chapter 3 is acceptable solutions for energy efficiency compliance after December 31st, 2016. So any permit that you submit to the city after December 31st, 2016, you need to adhere to chapter 3 of this document, which is the SB12 document. Now, depending on where your house is located, you need to figure out whether it belongs to zone 1 or zone 2, because the first sentence here, it says Article 3112, the building location, there's 2 zones in Ontario, less than 5,000 degree days or more than 5,000 degree days. If you don't know what heating degree day means, you should Google it. The quick answer is basically how many degree days it's related to heating. So in Ontario, like in Toronto, the heating degree days is about 3,500-ish. But if you go to like Sudbury or Thunder Bay, it's going to be over 5,000. So that's the determining factor for you to locate whether you're zone 1 or zone 2. Now, why is this important? Because you're up north more. It means that it's colder. It means you need to use more energy to keep the house warm. And when you need to use more energy, the building code SB12 requirement tells you that, oh, you're going to use more energy, then I'm going to make sure you make your home more energy efficient. So when you look at the different requirements for zone 1 and zone 2, there is a slight difference in the mechanical system and also the building envelope of your building. So that's why you need to make sure that whatever this project is located, you need to identify that. Yes, question.
So Jack, would you prefer our questions, we save them to the end, or ask you as you are going along?
You know what? I like it to be interactive. So if you have a question, just raise your hand, just speak out.
Question number 1 then.
Okay, please. Let's make it interactive.
So we usually hear there's the different zones in Canada, like zone 5 and zone 6 and zone 3 and 4. So this one's only zone 1 and zone 2. So
Yeah.
that's kind of confusing for people who don't know. So can you explain when we look at the overall zones and when we look at zone 1 and zone 2, like how they fit together?
So the first zone that you're saying, zone 4, 5, 6, and 7, that is a national building code way of determining heating degree days for the national building code. The current building code for Ontario is just zone 1 and zone 2. So basically, zone 4 and 5 of the national building code is zone 1 for Ontario.
And how do we find out what zone
They belong to? So you need to determine the heating degree days of.
Yeah, so we go back to the chart in SP3.
Yep.
Will you be doing that today, or that's a different?
No, that's, but okay, so how do you determine? So there's a few ways for you to determine the heating degree days of your project. The first one is you can ask your HVAC designer and say, here's the address, what is the heating degree days? They can tell you. And then there's also a link that I can share with you later on that allows you to click on the put in the address of the house, and it's an Enercan link. It tells you what the heating degree is based on the address that you enter. And from there, you'll know what the heating degree day is, and then you can figure out which zone it belongs into, 1 or 2.
So then you go to SB3 and it'll tell you zone 1 or 2. Is that the next step?
Not SB3.
Then where?
It's here, this chapter,
Oh, this chapter.
SB12. Yeah,
Oh.
SB12 chapter 3. So if it's less than 5,000 degree days, it's zone 1. If it's more than 5,000 degree days, it's zone 2.
Okay, I'm just because not everybody knows. That's why when I told you we can start from zero knowledge. So
Yeah.
I was wondering if you were going to cover how we get to that particular.
Okay, so I need to find the link for you, and then I'll show you how to get figure out how to do the zone. So when we take a break at in a like sometime in between the session, I'll get the link and then I'll share with you. Actually, you know what? Here's another. Yeah, I'll get you the link because that's the best way for you guys to identify where that zone is. Okay.
Yeah. Hi. I have a
Yeah.
question. Can I ask?
Yes. Go ahead.
Yeah, it's my responsibility as architect to determine the zoning, or the HVAC mechanical engineer, he has to tell me that you are in zone 1 or zone 2, usually here in Canada, as a
So
process.
basically, you or the HVAC
Both.
can both determine this. Even an energy advisor like myself can help you determine that.
Yeah. Okay.
Because that's something that you need to basically find out. So let me send you a link, and you guys can actually. Okay, I'm gonna send you a link right now. Okay, on the chat, and you guys can explore it there. But you guys got the link on the chat?
Yeah, I'm just asking these questions because in some project I work on, I choose the zoning. It was clear it's zone 1, but because we have a big windows, the mechanical engineer, he changed the way he calculate the lose and gain calculation and everything. He changed everything.
And so we'll cover that later on, okay? Let me just walk
Okay.
you through. So the link I just shared with you guys, it's here, and you just type in the city of where you are. It will tell you that the location, the region, and then it will tell you the heating degree days. So the heating degree days for this one particular location in Markham is at 3,863. So that's your annual heating degree days. So if it's under 5,000, therefore is zone 1. All right. Now, if you did this, let's say Sudbury, you know, Sudbury. So that's 5,049. So that's zone 2. Does that make sense to you guys now? How you can find out your heating degree days?
Yes.
Okay, so this link is very important. So you can save that. It's on the chat now. So that's heating degree days. So let me go back to my other screen now. Okay, so because you need to read the right, you got to go to the right chart to read your requirements. So I'm gonna keep going now. Okay, so here's another sentence that you really need to read, to get hold of. Okay, so what this is saying is that we build houses and there's windows that we install, right? So the current building code only focuses on sliding door, skylights, and windows, and glazing in the doors. Those are the glazing area we need to do. If your building is between 17 and 22% in window to wall ratio, your windows has to perform better. When I say better, what it means is that because you have a lot of glass in your home, the more glass in your home, because glass are less efficient than insulation, they will make you to install better performing glass. And this is that one sentence that says that if you have a lot of window in your home, you need to improve the window performance. That's what you need to understand on this one chapter here. I highlighted for you because this is one part that a lot of architects will be confused. There's this sentence here. You'll understand what these values are later on, but let me just plant a seed here and let you know that if you build a house that has between 17 and 22% window to wall ratio, you need to increase the performance of your window. All right, that's first requirement. Now, the second sentence I highlight here is if you design a house that has over 22% window to wall ratio, then you have to do energy modeling. You cannot do prescriptive path. So we will cover that in second day, not today. Anybody have done a house that's more than 22% window to wall ratio?
Yeah, I did one.
Okay, so you had to use an energy modeler to comply, correct?
Yeah, exactly. He used these things. Yeah.
So that's the reason why, because this is where it's saying that, all right? So I just want to let you guys know. Now, I'm going to start going through more requirements here. Now, sentence 17 is also a very important one. Anybody who built up north where they use a wood stove as a heating system, or a geothermal system, or a air source heat pump system that has a natural gas backup, if you use any of these systems I just mentioned, you can use any of the compliance package I'm about to show you to meet compliance. So anybody have designed a wood burning appliance or used a geothermal system in the past?
No.
No? Okay, that's fine. I'm just planting a lot of like, seeds here because you're going to come back to it and understand why I'm saying all of this later on. So just if you're like not sure where I'm trying to go with this, I'm just trying to plant a lot of seeds so that when you look at the tables later on, you understand what I'm trying to convey to you. Okay, so this sentence is really important. Sentence number 17. Okay, so let's talk about the energy efficiency for buildings located in zone 1. So again, zone 1 is less than 5,000 degree days. That's zone 1. So everything that we do, everything that we need to build, it really depends on the location of the building. So that's really zone 1. Now I'm gonna skip all these little requirements because these are something that you can read, but it doesn't impact like what you do. But this is the table I want you to learn. Now you see this table 3112 SI. SI is basically metric. So metric is what like US digits. Now I am trained as an architect as well, and I like imperial. Which table do you guys prefer to use?
Imperial.
Imperial? Everyone okay with imperial?
I think there's a mix, so maybe we can go over.
Okay, we can go over both, okay, right? So I just want to let you know that there's two tables here. One is SI, SI is metric, and then the next one is the same table, but it's in imperial unit. So let me just go through this table one by one. Now, once you learn how to read one table, you'll be able to read the whole table. So let me just walk you through this one at a time. So most builders in Ontario, I mean like 90% of builders in Ontario, they comply with the A1 package. It's simply because A1, which is this package here, and where it says walls above grade, this is the only location that does not have something called CI. So what is CI? CI stands for continuous insulation. So just remember that for now. CI stands for continuous insulation. So let's look at how this table is set up. So when you're building your house for the purpose of meeting SB12 requirements and you're in zone 1, you can comply with this building code requirement using 6 packages. So A1, A2, all the way to A6. In order for you to comply, you have to do everything within the one column. You cannot pick and choose. If you're going to go with A1, everything of A1 you have to do in terms of meeting compliance. All right, you cannot pick and choose. So let's talk about what you need to do to comply with A1. So here's it, ceiling with attic space. Ceiling with attic space means that your roof has an attic space. That's very typical. So anytime when there is a, airspace within the roof where you can add insulation in, that's ceiling with attic space. And in order to comply with this, there's 3 ways that you can do to comply. So there's minimum RSI, maximum U, and effective RSI. In order for you to comply, you do not need to meet all 3. This is 1, this is 2, this is 3. You do not need to do that. You only have to pick one of them. So what is the difference between nominal, max U, and effective RSI? Nominal is basically whatever the insulation is rated. So in this case, this is rated at 10.56. That's about R60 in terms of imperial. So as long as you say, I'm going to put in R60 or RSI 10.56 insulation in my attic, you have met that requirement. That's number 1. Now, max U is actually the reciprocal of 10.43. So 1 divided by 10.43 equals to 0.096. So this 2 number is their inverse proportional. So it's 1 divided by 10.43. That is max U. So what is effective RSI and max U? So effective RSI is actually the actual performance of the building envelope, including thermal bridging. Anybody understand what thermal bridging, or does not understand what thermal bridging is? Just a show of hands so I can maybe elaborate more.
Maybe I did not get what does max U means. If you can repeat that, please.
Yeah, so max U equals to 1 over R. That's what max U is. So 1 divided by 10.43 equals to 0.096. That's how these 2 numbers are related.
So R is the effective RSI, not the nominal.
No.
All
effective,
right.
yeah. U value is 1 over effective RSI. So USI, like this U value, this 10.96 equals to 1 divided by 10.43.
All right, thank you.
That's what that is. That's how they're related, okay? But how do I calculate effective RSI? So if you guys remember the 2 files I sent to you, you guys can open it up later, but let me just open it and I can show it to you. Can you guys see my screen still?
Yes.
Okay, so now you see ceiling with attic space, right?
Yeah.
Okay, so here again, U equals to 1 over R. 1 divided by 10.43 equals to 0.96. Do you remember these numbers? We just saw that earlier, right?
Yes.
So that's what that is. Okay, so how did the government came up with this 10.43? In order for you to calculate the effective RSI of a building envelope, you need to hire an energy consultant like myself to come up with this number, 10.43. And the way you calculate effective RSI is by identifying how the building envelope is constructed, and then every element or every layer of material that you install in the roof, you assign a effective RSI to the building envelope. Now, as an architect, I do not expect you to be able to calculate the effective RSI. But what you should understand is that the effective RSI includes all the elements that is put together to make the building envelope. In this case, it's ceiling with attic space. And part of it, it includes the framing, it includes the insulation, it includes the drywall, it even includes the air film. So that's how they came up with the 10.43 within the building envelope. So looking at here, I'm going to go back to the drawing here. So how did they came up with 10.43? So that example that I showed with you, I just showed you how they came up with 10.43. All right, which is here. So you guys can look at it later to.
In other words, Jack, they took the standard construction type for a roof.
Yes.
Broke down the elements, and those elements, each one has an RSI. They added them up, and they got this 10.3.
10.43, correct.
Right
now,
okay.
Yes. So you as an architect, you can say, I don't like the way you're building this. I'm gonna do it my way. You can say that, right? Because you're allowed to do like passive house. They would be like R80 in the attic. So as long as you meet or exceed any of the 3 numbers here, like these R values, you are deemed compliant. You have to meet or exceed those numbers to meet compliance. So if you decide to go R80, you can do that.
I
So
have
So-
a question.
Fair to
I
say,
have a question.
sorry. Let's go back to raising hands.
Yep.
So just my question is, so who uses the nominal, like are there specific, like most people use, most architects, let's say, use the nominal, and if you are designing something unique, you would use the U or the.
Effective. Yes, correct. Correct. So as an architect, it's the easiest for you to just meet with the nominal R value as an architect. But sometimes when you have unique projects where you cannot meet the nominal RSI, then you can meet it with effective or max U value.
Okay, Muhaddin, you had a question?
Yeah. Let's say if we have existing materials, how we know that these materials, the R value or the RSI for this material,
There's a table.
Yes,
to
there's a
exceed
table.
the,
So there's a table. ASHRAE's got tables. The building code's got tables. I can also share a document from Natural Resource Canada with you to show like the effective RSI of different elements. But honestly, that is not really meant for the architects. I mean, you guys are welcome to learn it. That will be a different training because it will take more time to go through this. But we know how to calculate these RSI values for you. So I just share some exercise with you to get there. So if you want that document, I can share with you at the end of the day as well. Okay, but I just want you to understand that for you to comply with the ceiling with attic space, you have 3 options, and you can go either this, the nominal RSI, or max U, or effective RSI. So that's either one will comply. Now, let's go to the second element, ceiling without attic space. So this one is like flat roofs or cathedral ceilings. Everybody know what I understand, like what I say when I say cathedral ceilings or flat
Yeah.
roofs.
there's
Okay,
no attic.
exactly. There's no attic space. So that's the main difference. If there's no attic space, you are deemed to comply with this. Okay, now sometimes you have a flat truss. So your roof is like flat, but you actually have attic space. That is actually here. On the outside, it might look like a flat roof, but if you have attic space in between, then that's called a ceiling with attic space.
One question: do we have minimum dimension of the attic, or it doesn't matter?
Well, minimum meaning like, you know, there's gotta be enough space to fit in the insulation value that we need. So, but there's no minimum volume or minimum attic.
Let's say if we have attic for 2 feet, it's considered as attic.
No, I mean, if you insulate the whole roof, then it's not, because there's no attic space. There's no like air space, you know? So I mean, if you want me to send me a sample, I can show it to you. But Samina, you have a question?
Yes, actually, are those tables taken from the Ontario Building Code or from the national building codes?
When you say those table, like the table you're looking at right now?
Yes, that you're
So-
sharing with us.
Yeah, so this table here is the Ontario Building Code, SB12.
All right, so do we have similar stuff in national building codes?
The National Building Code is constructed a little bit different. I also happen to wrote training manual for that, so I can have another session with you guys if you want, but it's a little bit different. The National Building Code separates them. The building, like the Ontario Building Code has all of them in one chart. The National
Yeah.
Building Code has it in different categories. So it's similar concept, but it's not the same format.
Yes, because we're like in the exact exam, we are required to use the national building code. So it would be awesome if you can share that with us, like how to do that using the national building codes.
Okay, well, we can talk about further training like later on, but for now, let's just talk about SB12, okay?
All right, thank you.
So again, there's 3 options, 1, 2, and 3 for ceiling. So again, nominal, effective, maximum U, or effective RSI. And now look at the first, 4, 5 options. So 1, 2, 3, 4, 5. Each of them all have 3 options for you to comply. And as long as you comply to either one of them for each of the components, you're deemed compliant. You do not need to do anything to show that you meet compliance. You do not need to do energy modeling that you show compliance. Exposed floor, most people just say 5.46 and that's it, R31. Okay, now I really want to show you walls above grade again, because something called continuous installation, CI. So CI is continuous installation. Most people use A1 because they do not require continuous installation. And when they use continuous installation, you also have to make your foundation thicker if you have brick. So it is the most cheapest wall to build if you use the A1 package, because there's no continuous installation required for this table. Okay, now, Sam, if you want to ask your question, just go ahead.
Yeah, just to confirm, like when you said you can choose between or A1, A2, A3. So it's up to the architect to choose which package?
Yes, or
Okay.
your client,
Okay.
But you have to make sure that your zone is correct,
Yeah.
right? You can't, so that's why the first thing is you need to know your zone.
Yeah.
And this one is zone, with the space heating equipment at 92%. Okay, so let's so
Thanks.
thanks for that. Okay, now here you see in the basement wall, again, you have 3 options, but every package have something called continuous installation. So your basement has to have continuous installation around the whole basement walls. And that is, can be outside the basement or inside the basement, but it has to be arts. So this is R20, which is RSI 3.52 everywhere. Under the building code, have you guys ever built a house that they finished the basement?
Yeah.
Yes. So in a finished basement, what they usually do is they'll do R10 plus a 2x4 with a R12 bat. So that's what number 6 says. Basically, under the A1 package, you could either do this or you can do this. These two are interchangeable. It's either one. And that's what note number 6 says. So because this is RSI 3.52, right? You see that? You could replace that wall with RSI 2.11 plus 1.76 CI. So this is the only time where you're allowed to change these two if you want to. And you do not need to get a building permit for that.
Can you
Yes.
explain what that means though? 2.1 plus 1.76 CI.
Yeah. So RSI 2.11 is about R12, like R12 bat in the frame, R12. R 1.76 CI is actually R10, continuous insulation. That's what that means. So this first number, it relates to the insulation in the frame cavity. The second number refers to the continuous insulation requirement. Yes, we have a question.
Yeah. Could you please go to the second schedule, the imperial?
This here.
Yeah.
Yep.
Yeah. Most sometimes when we send to the cities for the basement, we have 12. It's existing, and we add a 10 are between the new stud. That it's mean 12 plus 10 that you highlighted.
No, that is not. So R12 plus 10, this R12 here refers to the bat insulation within the frame cavity. This R10 refers to insulation outside of the frame, which is continuous insulation.
This
So
is on the wall, that's stick on the wall, yeah?
That's correct. That's the rigid insulation that you put on the wall, and then you do the 2x4 in front, and then you do the R12.
So
Oh.
both are required.
Sorry?
Both are required, the rigid insulation and the insulation between studs.
Yeah,
Okay.
both are required.
All right.
Yeah, but in this here, this R20 CI is just an R20 blanket. And that's what most production builders use because R20 blankets are very, very, very cheap. The cost to do an R20 blanket is about $1 a square foot. That's it. Very, very cheap. This here is almost like $2.50 per square feet. That's why most people, most builders, I know they use R20 CI. All right, I'm gonna move on to the next section. Okay, so that's basement walls. This here is below grade slab under the whole house. So this is where the slab touches the earth, and that could be your basement. Now, if you have a basement that is more than 600 millimeters below grade, so more than 2 feet below grade, you do not need to insulate that slab. You do not need to insulate that slab. That's why this dotted line means no insulation. But if you have a heated slab or a slab that's less than 2 feet or 600 millimeters below grade, so like slab on grade, that's also one of them, you need to install R 1.76. So R 1.76 is R10, rigid insulation below the slab. Now, when you have heated slabs, so that's radiant floor, if you don't add the insulation under the slab, then all the heat will go to heat the earth because the earth is always cooler than the house. And heat always goes from hot to cold. So if the earth is cooler than the house, then the heat will go down to the earth instead of heating the house. That's why you need to insulate under the slab. Yes, question?
Yes, I had a question. So if the slab is above the grade by 600, but it has like a crawl, like a void underneath it. What would that
Like a
be?
crossface?
Yeah,
How can it have a, like, you have a slab and then a void?
so this, it's an elevated slab and there's nothing underneath it.
Oh, okay. What about,
What-
and
what-
that, so like you have a house and then there's a void here. And
Yep.
then you have gravel.
Yep,
Um,
foundation goes below that, like the foundation goes 4 feet below, yeah,
so like something like this.
yes,
Where's grade? Is grade here?
no, down.
Grade down here?
And then there's 4 feet to the footing.
Yeah, so that's right. So here, there should have been installation. If grade was here, if this was grade, let's say that was grade, then there should have been installation here.
Okay, which installation would we go with? The one that's below?
They
below
don't tell you what type of installation, they just tell you how much installation.
Yeah, that one below 600. So it's
Yeah.
considered slab on grade,
That's correct. And you need to insulate that.
but the slab is up the top. There is no slab down there.
Yeah, so it doesn't matter because we assume that the soil needs to be insulated because
Mm.
heat should not go there. So that's a weird detail. Like it's really rare to see that there's the slabs up here because this is not even a slab. This is probably like, is this built with concrete or built with wood?
Concrete.
Okay, so that's interesting. But here there should be insulation here. If let's say if this is earth, you're telling me this is earth, right?
Yeah.
Then there should have been insulation here, right there, R10, which is R1.76,
Maybe rigid insulation
or spray foam.
or
It could be
spray.
spray foam, but it has to be R10. They don't tell you what material, they just tell you what insulation. Okay,
And
now yep,
if that's same detail, if you backfill it, like remove the concrete flooring and backfill it and then put the insulation, what would that be?
still R10.
Still R10.
Yeah, still like, which is 1.76 RSI.
So it wouldn't go beyond the top one, like wouldn't it be oh, because it's below. Okay, yeah, all
Yeah,
right.
yeah, okay. And then, so this here is edge of the slab. So the edge of the slab, let's say you have a foundation here. And then you have your slab here. And this is a slab on grade. So the R10 can be applied here, or it can be applied here. It's up to you. So like the insulation, let's say this is your slab. That's where it also has to be R10 basically. Or you can do it like this, and then you can have insulation like that. That's R10. So that's what this is. This is where the edge is. Like the edge refers to the edge is the slab where you're touching the footing.
Okay, I think the horizontal one is the more used, correct?
Yeah, that one's more used because it's easier to do. But again, there's a requirement for it. It's R10. All right, so this section here covers the insulation and the building envelope of your house. Now this here is where it starts to be interesting because windows, there's 2 ratings that you can comply, 1 or 2. So you can use max U and energy rating. Now these 2 things are completely separate metrics of window compliance. There's no correlation between them. All right, there's no correlation. So what you need to understand is for this window, I can either meet with U 1.6 or I can meet with an energy rating of 25. All right, you don't have to meet both. You just have to be either one. Similar to these, it's 1, 2, or 3. You do not have to meet all 3. You just have to meet either one. So here is where it's very interesting. You can have a window that is at energy rating, so it's called ER, at 34. And the U value could be at 1.8. But because the energy rating is at 34, it will comply with ER rating and you're good. You are compliant. Even though the U value of 1.8 is worse than 1.6, you're still okay because you meet it using an energy rating. Now, hold your thought for a second because I'm going to tell you what table that is. If you guys go to table, this page here, I'll just tell you what table that is. It's down here. So just give me 1 second. You see this here? Table 3119. Maximum U and minimum energy rating for windows, skylights, and sliding doors. So 1.6 is equivalent to ER25. 1.4 is equivalent to ER29. And 1.2 is equivalent to ER34. So the example I gave you earlier was ER34 with a U value of 1.8. It could happen like this. Now, if you look at the U value, it's this. But if you look at the energy rating, it's here. So if you had a window that has this rating on it, you could actually say it complies to a U 1.2 rating. Any question here? This one is very critical. So
in summary, are you saying that we either comply with the ER or the U? Like,
that's correct. And whichever it's to your favorite, you can pick that to help you. Because if you can look at a window label and it says U1.8 or U34, you can say that this is, this window is actually equivalent to a U value of 1.6 or 1.2, sorry. So here's the thing, U value, the higher the U, the less efficient it gets. The higher the ER rating, the more efficient it gets. So that's the confusing part between U value and energy rating. You see, 2.8 is the worst, and then lower the better. Energy rating, the higher the better. That's the main difference between U value and ER rating. But as long as you comply to either one of the number, you can say you're complying to U 1.2 if you had a ER rating of 34.
okay, that's straightforward. Yep, thank you.
Now, here's the next thing I want you to learn. Remember in the beginning, I said if your window is between 17 and 22%. So under A1, the U value was 1.6, right? That was the A1 U value. Everybody remember that? ER25, we just went through that quickly. These were the two requirements for Windows. Now, if your window to wall ratio was between 17 and 22%, this 1.6 has to change to 1.4 or ER29. That's what I wanted to, that's the seed I planted earlier. So when your window to wall ratio is between 17% and 22%, and the A1 value says it has to be at 1.6 or ER25, then because of that requirement, you need to install Windows that's at U 1.4 or ER29. And that's this requirement here.
More efficient, so more a higher efficiency.
Higher efficiency. Because Windows are less efficient. That's why if you have more Windows, you have to improve the performance of the Windows.
What if it's more than 22%?
You have to do energy modeling.
Oh, yeah.
So that's next week, okay? Now let me go back to the slide and we'll finish up soon. So this, as I said, 1 hour is very challenging on online, let alone, you try to learn most of it, but I'll do my best and we can have more sessions. Look, what you guys are doing, Lola, like you're amazing. I want to help you. So if I can, let me know. I don't want to be off the hook. So if you know what I mean, if you need help, so just let me know. Okay, so let me continue using this. So space heating equipment, right? Sorry, skylight. Skylights, there's only one option. It's just the U value of 0.49. That's it. You have no energy rating for skylight. It's just the U value of 0.49. So pretty straightforward. For space heating equipment, oh, this is the SI, so I'll go back to the Imperial one. So space heating equipment is 96%. This is the AFUE number of space heating equipment. So this is a natural gas furnace, 96%. You cannot be 95.9%, has to be 96%. The other thing is the HRV. You can also install an ERV or HRV, but it has to be at 75%. And then if you,
Where does it say ERV though? I missed that.
okay, so going back to here. Note number 16, ventilation system serving dwelling unit shall have a heat or energy recovery ventilator. So HRV is
Mhm.
heat recovery ventilator, and then this one's energy recovery ventilator. So they mean the same thing.
Okay.
Okay, so that's where it is. And then if you're gonna install a domestic water heater, it has to have a minimum energy factor of 0.8%. So 0.80 basically. So that's basically how you would read the A1 package. Now that you understand how to read A1, the rest is the same understanding. You just have to understand that the first number here that you see, this represents the insulation in the frame cavity. This number. The second number represents the continuous layer of insulation outside the wall. So I'm going to go to the next table here because this is what it is. So basically for the A2 package, R60, R31, and then exposed floor, R31, they're all the same. But then when it comes to wall above grade, is R19 plus 5. So it's a 2x6 wall with an R19 back plus a R5 exterior insulation. That's what you mean by R19 plus 5 CI. Similarly, in the basement, it's a 2x4 R12 flat plus a R10 continuous insulation on the outside. So because you have better walls, that's why your hot water tank can be less efficient. And that's how they set up the whole table. If you do better on your walls, your mechanical system can be worse. If you do better on your mechanical system, your above grade walls can be a little bit worse. And then depending on how your client wants to build, you can pick any of these packages. Any question on how to read these numbers?
So I guess with experience, we would know R12 is 2x4, R20 is, or 14 is whatever, like
Yeah.
and what these are in terms of wall thicknesses.
Yeah. So if I mean, wow, I mean, that would be very, basic construction. I think like for people who came from other countries where they've always been using concrete as their main primary building material, yeah, those will be good for them to learn more about like Canadian plywood framing, right? because I lived in China. We had no wood there. It was all concrete and it sweats in the springtime. So I totally get it. I mean, if that's like a request, I mean, SB12 doesn't cover that, right? Because they assume you already understand that. But I could have another session and talk to you guys about like, what fits in a 2x4, what fits in a 2x6, and what goes into a 2x10 and a 2x12. We can have a session on that, but I don't think I have enough time today to cover those kind of knowledge.
Yeah, if you go to Home Depot, they will put all the schedule for every all the art and the dimension of the insulation. We can find it there.
Yeah, or there's a really good book called Canadian wood like lightwood framing. That book is really amazing. It would teach you a lot of the way we built houses using wood. So that's a really good book. I can share the title of that book with you guys as well.
Thank you, Jack. But in general, I mean, mostly I've seen A1 and A2 packages, right? Like those are the most commonly used.
Yeah, so for me, I see a lot of A1 and A4.
A4.
Yeah, A4 is when you use a combination system. If you don't know what a combination system is, for for those who wants to learn, it's actually like one equipment that does both space heating and hot water heating. That's what a combo system means. And a combo system is usually used in a townhouse development because there's very little room for venting. That's mechanical challenges. For those of you who doesn't understand what like mechanical systems are, there's so much you have to learn in terms of like a house construction. But A4 is meant for a combo system. That's the package. But A1 is mostly used, and A4 is most people just you know, if it's a combo system, they have to use A4.
Understood. Yeah.
So, Jack, can I ask you for a favor for this next session, please?
Yes.
So if you can prepare like 2 cases where like you ask us to calculate what's required for energy and stuff like this. And
Yep.
we can like do the calculation and try to figure out the numbers. Is that something that's possible?
Sam, yeah, that would take up too much time. I think maybe he can send us something that we can work on offline and then present it to him.
Okay, so let me just rephrase the question. Do you want to learn how to calculate energy consumption using the performance path? Is that what you're trying to say? Or
Not
trying to learn?
really. Like how to find like the numbers, how to get the numbers out of those tables. So maybe you
Okay.
can send us that this wall is from this building, it's above grade, and calculate or find the
Okay,
numbers.
so I gave you some examples to the earlier. So if Lola, if you can reshare them with your team.
I will. Yeah.
Yeah, so basically this here, right? Like more of this example, is that what you're asking for?
Yes.
I think she means if you have a wall type, like say a wall thickness, a wall type, a wall assembly, and then try and calculate the which package should comply.
So I have those examples given to you. We don't have time to go through them right now, but I gave you these are examples that where you could find the RSI and calculate and come up with these R values. If I can, I will share the answer key with you, Lola, just with you, and then give them like, some time to play around with. And then if you want, you can share with your team. That way they can learn from like trying it on their own and then get the answer key.
Okay.
This is what I make the CBOs go through when they try to learn, because when they review building permits, they also have to verify that you are doing the right assembly to comply. So I had to teach them how to do this job as a plans examiner. But for architects, I think it's too much to learn in 1 hour. This is a half a day exercise, not a 1 hour exercise.
Okay.
Yeah.
Yes.
Yeah. So, I mean, next week, what we could do is so all the table, as long as you learn how to read one table, then they all is the same understanding, same logic, same everything. So it's not hard to understand. Next week we'll learn about the performance compliance, which is this table here. It's this section here, performance compliance, because a lot of you will design houses that are gonna be over 22%, then you need to work with an energy modeler to come up with the building package. You cannot select one of those tables. And this is what I can walk you through. At least you understand the purpose, and then you can hire the right person. Now, you don't have to hire an energy advisor to do energy modeling. You, as the architect, can also learn how to do it and submit for a permit. It doesn't have to be me. But next week, I'm gonna walk you through all the rules, 7 rules here, so that you understand what it takes to model the house properly.
Great, that's exciting, Jack. Thank you so much for your time and for taking the time to in your evening to be with us. We really appreciate it, and we look forward to next week. Maybe we as a group can prepare some questions, like read it beforehand, this
Yeah.
chapter, prepare
Yeah.
some questions,
Yeah.
and we come prepared.
Okay. So 1 hour to teach SB12 is very hard. The presentation that I made for the CBOs, it's a half-day training, and that's like the minimum for them to go over. So I'm more than happy to help this group to learn more about SB12. And if there's any questions you may have for your future projects, you can share my contact information with them, and you guys are more than happy to ask the questions for me. Because I want to be the person I wish I had when I first came to Canada as well. So I'm being that person for you, and I hope that whatever I can do that makes your life just a little bit easier, then it's all worth my time.
Thank you, Jack.
That's all I wanted to say.
You know how much we appreciate that. Thank you.
Yeah. So don't be shy. Keep calm and call Jack. That's what I say to the CBOs, because they have so many questions as well. Even they work with the building code, they have so many questions as well. So it's not just the architect, everybody has questions, but this is what I do as my professional career. So I
Okay.
am yours. If I can help you, please let me help you. And it's my
Thank
honor to be
you.
able to help.
Thanks.
Thank you.
Have a good
Okay.
night, everyone. Thank you, Jack.
All right, that's it for today, and I will see you guys next week. And if you have a lot of questions, please send them ahead of time. If you want to, like, maybe Lola, if you can collect all of them,
I'll
and
collect.
then like even questions about today, because this doesn't have to be a 1 day or 2 day session, because I understand, and thank you. I appreciate you giving me the chance to escape, but I don't want to. I want to help. So if there's more that you need, just let me know, and I am more than happy to help you. All right. So
Sounds good.
that's all I can say.
Thank you so much. Thank you. Okay.
Okay. All right,
Night.
guys. You guys have a great night, and I will see you next week.
Thank you.
All right,
Bye.
take care. Bye for now.
Right.
Oh, good night.